Hello, and welcome to Math with Usna. In this lesson, we're going to prove that triangles are congruent. We're going to introduce these proofs, and we'll learn how to construct a proof for triangle congruence. Now, we've talked about the reflexive property, the symmetric property, and transitive property before. The same properties apply to triangles. If you have a triangle, then you can say that it's congruent to itself. That's the reflexive property. If you know that two triangles are congruent, you can write that congruent statement in either direction. So they are the same thing, no matter what direction or what order you write them in. And the last one, transitive property, if you have two triangles, JKL and ABC, for example, that are congruent to the same triangle, then they're congruent to each other. Before we actually get into doing a triangle proof, let's just talk about a congruent statement. We know what congruent statements are for segments and for angles. We've written those before. For example, AB is congruent to CD. That's a congruent statement for segments. You could say angle A is congruent to angle B. That's a congruent statement for angles. We can also have congruent statements for triangles. And what you're going to do is look at one triangle. So just choose one triangle. I'm going to choose the one on the left, and I'm going to name this one however I want. I will just say triangle XDZ. And I'm going to put is congruent to. Now this is the important part. The triangle notation for the second triangle has to correspond with the first one. What that means is I have to make sure that I match up the angles that are congruent when I'm writing my second statement. Let's see what we're talking about here. We've got angle X or point X first. And in my diagram, that's right there. I want to look for the matching one in the other triangle, which is Q. That means that my notation here is going to start with Q because that's the one that corresponds with X. All right, now let's do the next one. I've got D, which is right here in my triangle. I'm going to match that up to the second triangle, which is W. So my second point is W. And then the last one, I could match it up. However, you should notice that there aren't any tick marks here. So technically, if you're just looking at it, you wouldn't immediately know what it's congruent to. But we know by the third angles theorem, if two angles of two triangles are congruent, then the third angles are also congruent. That means we're going to end with P over here. So in a congruent statement for triangles, you want to make sure that you match up the corresponding parts. When two triangles are congruent, they have three sets of congruent sides, and they have three sets of congruent angles. You want to make sure you match that up. Let's say I didn't have this image at all, right? So if I didn't have this picture, I should be able to identify all the corresponding sides and angles just from this congruent statement. Let's go ahead and do that. I'm going to look at my first 2 points. That has to match up with the first 2 points in the other triangle. That tells me that XD, that side, is congruent to QW. And if I look at my diagram, XD and QW are in fact congruent. My next one, DZ, is congruent to WP. DZ is congruent to WP. And the last one, X and Z, are congruent to QP. XZ is congruent to QP. So I've got three sides from that congruent statement. Now let's do angles. So I'm going to go ahead and erase this. Okay, angles. Angle X has to match with angle Q. Angle X has to match with angle Q. Angle D has to match with angle W. Angle D is congruent to angle W, and angle Z is congruent to angle P. Now, if you didn't have single angles at those points, and I had to use 3 points to name the angles, how would I do that? you could draw out this triangle. If you weren't given the triangles, you could draw them out and use that drawing to properly name your angles with 3 points. So instead of saying angle X, I could say angle DXZ. And I got that from my picture. DXZ is how I would name that angle with 3 points. Instead of saying angle Q, I could say angle PQW. So you can name the points either way with 1 point if it's acceptable, or you could always name it with 3 points. Let's do an example of a proof. When we're proving that triangles are congruent, we have to prove 3 sides and 3 angles. I already started off by putting my givens in there. I want to put them in the diagram as well. So angle A and angle N are right angles. Whoops. I can see that I already have the notation for right angles in there, so I don't need to do anything. DA is congruent to NG. I'm going to put the tick marks there. Q is the midpoint of AN and DG. Now, if your intuition is telling you that you should put tick marks in your diagram, you're correct. However, because we have actually made that statement that there are congruent segments, we're not going to put it in our diagram yet. We will, but we won't do it just yet. So we want to prove 3 sides and 3 angles. Let's start off with the sides. We already have 1 pair of congruent sides. We need 2 more, and I'm going to get it by using the fact that Q is the midpoint of AN and DG. If Q is the midpoint of AN, that means AQ and QN are congruent. That is by the definition of a midpoint. If it's also the midpoint of DG, that means DQ and QG are also congruent. Notice I'm using different tick marks here because I want to separate them from the other congruent segments. We've got the same reason, definition of midpoint. All right. Oh, that should be a 3, not a 2. So now I have 1, already highlighted, 2, 3 congruent sides. That part's done. Now I need to prove 3 congruent angles. Now look at the givens. We've used this, that the sides were congruent. We used that Q was the midpoint to get our step 2 and our step 3. We haven't used this yet, the A and N are right angles. What does that mean? If A and N are right angles, that means that they're congruent. Angle A is congruent to angle N because all right angles are congruent. It seems like an unnecessary step, but when you're doing these proofs, you have to very clearly say these 3 segments are congruent. These 3 angles are congruent. You want to be very clear about writing that out. We've got 1 set of congruent angles. Now, I don't have anything else given to me. All right, I've gone through all of my given statements, and I'm still not done with my proof, which means I'm going to now look at my picture. What angle pairs do you notice in this picture? I want to prove that D and G are congruent, but I don't really see a way of doing that just yet, so I'm going to move on. I also want to prove that DQA and NQG are congruent. I do see a way to prove this. These 2 angles are vertical angles. I'm going to go ahead and say DQA is congruent to NQG. And that is because vertical angles are congruent. Okay, I've got 2 congruent statements about angles. And since I've stated that these are congruent, I'm going to put those tick marks in there. And now I've got 2 triangles that have 2 pairs of congruent angles. By the third angles theorem, I can say that angle D is congruent to angle G. That's the third angles theorem. And I'll put that in my diagram. So I have 3 sets of congruent segments and 3 sets of congruent angles. Once I have that, I can now jump to my proof and say Because all the angles are congruent and all the sides are congruent, my triangles are congruent. That is the definition of congruence, the definition of congruence. If all the parts are congruent, then the shapes themselves are congruent. If you learned something, please like and subscribe and stay tuned for more videos.